Alright, we have worked out the compound angles, we know the double angles. Now what if we're told to work out theta? Well, let's take a look at this question. Show that sine theta plus pi over 4 is equal to this. Well, if you remember from the previous class, sine theta plus pi over 4 is the same as 2 sine theta, what am I talking about, is equal to sine theta cos theta, cos pi over 4 plus sine pi over 4 cos theta. Cos pi over 4 is equal to sine pi over 4, which is equal to 1 over root 2, or root 2 over 2, okay? So therefore this is 1 over root 2 sine theta plus 1 over root 2 cos theta, which is equal to 1 over root 2 sine theta plus cos theta, okay? So now, hence or otherwise, solve the equation 1 over root 2 times sine theta cos theta is equal to 1 over root 2. Biggest red herring I've ever seen in my entire life. Why? Because what the examiner wants you to do is they want to be like, oh, this is equal to 1 over root 2, so we can get rid of... No. Red herring. Remember, this is equal to this. Okay? So what we can say is, not only is that equal to 1 over root 2, but sine theta plus pi over 4 is equal to 1 over root 2. Okay? Which means that theta plus pi over 4 is equal to inverse sine of 1 over root 2, which is pi over 4, 3/4 pi. No? Yes, 3/4 pi. And then it would also be equal to 2¼ pi. Alright? Then we minus this from each side. So theta is equal to 0, pi, and 2 pi. Okay? So now, using my answer to part B, write down the intervals to the solution whereby sine theta plus cos theta is equal to 1. All over the same interval. Well, remember, if sine theta plus cos theta is equal to 1, then therefore sine theta plus pi over 4 is just going to be 1 over root 2 times 1, isn't it? Because we're just using this. So therefore, theta is still equal to 0, pi, and 2 pi. Okay? Is this video helpful? Well, make sure that you subscribe so you never miss a video like it. Now let's take a look at this example. For this one, show that 3 cos squared x minus sine squared x is equal to 1 plus 2 cos 2x. Well, 3 cos squared x minus sine squared x. This is where we use the double angles, right? Because, I'll do this in black. Cos 2x is equal to cos squared x minus sine squared x, which is the same as, depending on what you substitute in, 2 cos squared x minus 1, or 1 minus 2 sine squared x. Okay? So all we're going to do is we're going to make these the subjects for each of them. By doing that, cos squared x is equal to 1/2 times cos 2x plus 1. Okay? And sine squared x is equal to 1/2 times 1 minus cos 2x. So now what we're going to do is we're simply going to substitute these guys in. This is the same as 3 times 1/2 times cos 2x plus 1. Okay? Minus 1/2 times 1 minus cos 2x. Okay? And now we can expand it out to get 3/2 cos 2x plus 3/2 minus 1/2 plus 1/2 times cos 2x, which is the same as 1 plus 2 cos 2x. And that is your final answer for part A. Done and dusted. Now let's look at part B. Sketch the curve of y equals 3 cos squared x minus sine squared x. Well, if we put this on a set of axes between pi and minus pi, you'll see that because we are adding plus 1, we're timesing everything by 2, we have to stretch it. So this is going to be at 3. Sorry. This is going to be at 3 because of the plus 1. Otherwise, it would be at minus 2 and 2. Okay? And what we're going to do is we're going to have to compress it as well. So usually this should be 2 pi. But because this is at 2x, we're only going to stop here. Alright? And it's the same on the other side. Do you understand? So because of this, we are compressing. Because of this, we are stretching. And because of the plus 1, the y-intercepts are going to be, this is going to be minus 1 and this is going to be 3. So we shift up by 1. So all this is using the rules of transformation of functions. Is this topic still not making sense? Well, you can join my Discord server and ask me whatever questions you want down below for fast responses guaranteed. Now let's look at this one. Given that sine 2 theta plus cos 2 theta is equal to 1, show that 2 sine theta times cos theta minus sine theta is equal to 0. Well, sine 2 theta is equal to 2 sine theta cos theta. So, therefore, left-hand side is going to be sine... it's going to be 2 sine theta cos theta plus cos 2 theta. Okay? That's step 1. Now we need to get the other equations out. To do that, all we're going to do is we're going to change this around, aren't we? Cos 2 theta is the same as cos squared theta minus sine squared theta. So therefore the left hand side just looks like 2 sine theta cos theta plus cos squared theta minus sine squared theta. Okay? We also know that this is equal to 1, right? So how can we rearrange this 1? Exactly. 1 is equal to cos squared x minus plus sine squared x. Okay? These two are going to cancel out. And if we put this on the other side, we get 2 sine theta cos theta minus sine squared 2 sine squared theta is equal to 0. And then we factor out the 2 sine theta to get cos theta minus sine theta. Okay? So now, how are we going to solve the equation for this solution? Well, we know that 2 sine theta is equal to 0, right? And we also know that then cos theta minus sine theta is equal to 0. So theta is equal to 0, 180, and 360. Okay? For this second solution, we can use this equation here to show that cos theta is equal to sine theta. And now what we can use, we can divide both sides by sine theta or by cos theta. Actually, by cos theta. So we divide by cos theta. And what we're left with is tan theta is equal to 1. So therefore, theta is equal to 45. Or if we add in 180, it's also equal to 225. And so those 5 values for theta are the final answer. Thank you guys for watching. I hope you learnt something new. You guys can get tutored by me by dropping me an email. We can organize a meeting and a quote, and you will pass your exams. Guaranteed. Keep on learning as you have no idea what you're capable of doing.